In this video, I will discuss some JEE Advanced PYQs from the topic Newton laws of motion. These questions have appeared between the years 2023 and 2014. Timestamps are given in the description box. You can watch parts of video if you are running short of time. I will discuss some 3 questions. This is the first one. A particle of mass m is moving in a xy plane such that its velocity at a point xy is given as v equal to alpha into yx cap plus 2x y cap, where alpha is non-zero constant. What are the force F acting on the particle? You can pause and up this question. Force is rate of change of momentum. Momentum is a vector. Force is also a vector. And momentum P is mass into velocity. It's a constant mass. So mass will come out. So m into dv by dt, and v is given like this. Alpha is a constant. So d by dt of this quantity, which is dy by dt, which is velocity component, y component, x cap plus twice dx by dt is velocity x component into y cap. You have to find the force on the particle, and Vy is the y component of the velocity, which is 2x into alpha. So y component is 2x alpha, and then x component of the velocity is alpha y. So this is I component, this is j component or y cap component. So 2 alpha is common, so this will become 2m alpha square x comma y. 2m alpha square x comma y. So it's option A. Vector concept written like this. So writing x cap, y cap, and z cap can write as coordinates. So this is x component, this is y cap component. E is the correct answer. So this is what I explained here. The force is rate of change of momentum according to Newton's second law, and momentum is mass into velocity. It's a constant mass system, so mass is not changing with time, so it will come out into d by dt of the velocity, which is this one. So alpha is a constant, so it will come out m alpha, and dy by dt is nothing but the y component of the velocity. Dx by dt is x component of the velocity, vx, and y component x component of the velocity is given here. So y component of the velocity is 2x alpha. Alpha has come out, the alpha square, and x component of the velocity is alpha into y. So alpha has come out and y is here. So 2 will also come out. So this one. So correct option is option E. This is the next question. A football of radius r is kept on a hole of radius small r, which is less than capital R, made on a plank kept horizontally. Whenever the plank is now lifted so that it gets tilted by making an angle theta from the horizontal as shown in the figure below. The maximum value of theta, so that the football does not start rolling down, the plank satisfies. Figure is schematic and not drawn to scale. So this is the plank. So as you keep lifting this plank, this end of the plank is fixed. At some stage, the ball will start rolling. So you have to find this maximum value of theta for which the ball starts to roll. You can pause and run this question. The forces acting on this ball are this weight of the ball, which is say m into g, and there will be normal reaction at two contact points. This one n1 and the second contact point n2. So these are the only forces acting on this ball. When it's about to lose contact, it will rotate about this point. The ball will rotate like this. So it will rotate about this point. So n2 will be 0 when it's about to lose contact. And taking the torque about this point 1, the torque to this n1 is 0 because it's passing through the point. And this mg can be split into two components. One is mg sine theta down the plane. This is a standard result. Inclined plane theta, weight component downwards, the plane is mg sine theta, and normal to the plane, it's mg cos theta. So mg sine theta will provide a clockwise torque and mg cos theta will provide an anti-clockwise torque. So when it's about to topple, these two torques will be in balance and the net torque about this point will be 0. After that, this torque will dominate and start rolling down. So at that limiting case, these two torques will be equal, and this distance from this point, that will be, that we can get from this triangle. This distance is r, and this distance is capital R. So this vertical distance will be is 90 degrees, will be square root of r square minus r square. This is a right angle triangle, hypotenuse capital R, and this side is r. So this opposite side will be square root of r square minus r square. So the distance of this force about this point is this one, and this force and distance r. So this will produce a torque mg cos theta into r anti-clockwise, and the clockwise torque is mg sin theta into the perpendicular distance is square root of r square minus r square. So it's about to topple, the net torque is 0. After that, this torque will dominate. M and mg can be cancelled. So from this I'll get tan theta equal to r by square root of r square minus r square. So I can construct a triangle theta, tan theta, it's r, and here it is square root of r square minus r square. So this means this side is, sorry, tan theta, right? So adjacent side is square root of, so the side product this square plus this square will come out to be capital R. So this is the same triangle that's here, 90 degrees. One side is R, the other side is square root, and this is capital R. Same triangle here. Okay, so from this I'll get sine theta as r by r. So first option, sine theta is r by r. So correct option is option A. A is the correct answer. The forces acting on this weight mg, which is vertically downwards, and there will be two contact points, normal reaction 1 and 2. So it's about to topple. This point will lose contact, so n2 will become 0. And the torque about this point C, mg sin theta around the plane produce a clockwise torque, and mg cos theta perpendicular to the plane will produce an anti-clockwise torque. So both the torques will be equal in the limiting case. So torque about point C, it's mg sin theta into this perpendicular distance is square root of r square minus r square. That's equal to mg cos theta into the distance is small r. So from this you get tan theta is r by square root of r square minus r square. That means sin theta is r by r. This is the triangle. So correct option is option A. This is the next question. A wire which passes through the hole of in a small bead is bent in form of a quarter of a circle. The wire is fixed vertically on ground as shown in the figure. The bead is released from near top of wire and it slides along the wire without friction. As the bead moves from A to B, the force it applies on the wire is option A, always radially outwards, option B, radially inwards, option C, radially outwards initially and radially inwards later, D, inwards initially, outwards later. You can pause and have this question. So this bead here has got a small hole. Okay, at the top point, the top of the hole will touch this wire. So force on the wire will be downwards. When it comes here at certain point, the bottom part of this hole will touch the wire and above point will be free. So the force here will be outwards. So initially inwards and radially outwards later. It's a trivial question. D is the correct answer. So initially at top of the hole, when the bead is at the top of the hole will touch the wire and the force exerted on the wire will be done inwards. After a certain point, the bottom of the hole will touch the wire and the force the bead will exert on the wire is outwards.